All right, so in this video, we're going to start by finding the x and y intercepts of specific type functions or equations, okay? We're going to deal with linear equations, we're going to deal with quadratic equations, and we're going to deal with absolute value equations, okay? Finding the intercepts here is pretty easy, okay, based on the skills that you should already have. Later on in the class, we're going to find the x-intercepts and y-intercepts of functions that are a lot more complicated, okay? The y-intercept should always be relatively easy to find if there is one. The x-intercepts, though, there can be, technically speaking, there can be infinite x-intercepts for, depending on how complicated the function may be, okay? In these examples we're going to do, the most amount of x-intercepts we're going to have is 2, okay? So think back to Algebra 1. One of the things you should have learned is that x-intercepts, to find those, you're going to set y equal to 0. You're going to replace y with 0. You're going to solve the resulting equation for x. To find the y-intercepts, you're going to replace x with 0, and you're going to solve the resulting equation for y, okay? So we've got 4 equations here that we're going to deal with. This is a linear equation or linear function. This is a quadratic equation or function. This is a quadratic equation or function, and this is an absolute value function, okay? So we're going to go through these 4 examples relatively quickly here, and just going through these steps to find the intercepts, okay? So we're going to start with this linear equation number 1 first. So to find the x-intercept first, okay, we're going to replace y with 0. So we're going to substitute y, we're going to substitute a 0 in there, okay? So 4 times 0, this is just 0, so that's going to leave me with an equation of 3x equals 12. I'm going to divide both sides by 3, and I get x equals 4, okay? So again, pretty easy process here. X equals 4, so in terms of an ordered pair, that means the x-intercept is at 4, 0. So write 4 units, and then place a point on the x-axis there, okay? To find the y-intercept, the place where the graph will cross or touch the y-axis, we're going to replace x with 0 this time. So where we see the x, we're going to substitute 0 in there. Again, that just goes away. That's 0. That leaves me with negative 4y equals 12. Solve that by dividing by negative 4. And I get y equals negative 3. So y equals negative 3 is the y-intercept. As an ordered pair, it's going to be the coordinates 0, negative 3. Okay, so we would go down 3 units, plot a point there, and that would be the place where the graph crosses or touches the y-axis. Okay, so linear functions, that's pretty easy. That's stuff you did back in Algebra 1, Geometry, Algebra 2. Okay, with parabolas here, quadratic equations, you should have seen this before too, but we're just going to review the concept. The x-intercept here, I'm going to replace y with 0. Okay, so I'm going to isolate x squared. I'm going to move the 4 to the left side. It becomes negative. Okay, and if I take the square root here, what happens is I get an imaginary number over here, which is not a real number, which means there is no x-intercept here. Okay, so this graph, when we get into graphing this parabola, is not going to ever touch the x-axis. Okay, so this function has no x-intercept, and that's okay too. Not all functions will have x-intercepts. All right, the y-intercept, remember we're going to replace x with 0. So pretty easy equation here. 0 squared is 0. 0 plus 4 is just 4. So I've got my y-intercept pretty quickly. Okay, so 0, 4 is going to be the y-intercept. All right. Now 3 and 2, they're very similar. The only difference is the sign here preceding the 4. Okay, but it does change things quite a bit in terms of the x-intercept. So again, we want to replace y with 0. All right, this should be a minus sign here. I'll go back and fix that a little bit later. So when I move this negative 4 over to the left side, it's going to become positive. Now I need to take the square root of both sides. This time I will get a real number, and I'm actually going to get 2 intercepts here because the square root of 4 could be one of 2 things. It could be positive 2, or it could be negative 2. So while the equation here in number 2 did not have any x-intercepts, the equation in number 3 actually has 2 x-intercepts. One at 2, 0, just to the right of the origin, and one at negative 2, 0, just to the left of the origin. Okay? The y-intercept here, we're going to replace x with 0, so y equals 0 squared minus 4. So that just leaves me with y equals negative 4 as my y-intercept. So this graph this parabola actually has 3 intercepts in total, 2 x-intercepts and 1 y-intercept, all right? And finally, we've got an absolute value equation or function here. So the x-intercept, remember, I'm just going to replace y with 0, okay? When we solved absolute value equations before, we talked about having like a case 1 and case 2, where this value was positive in case 1 and negative in case 2, but 0 is neither positive nor negative, so we can just go right ahead and set x plus 7 equal to 0. So I get negative 7 as my x-intercept. As an ordered pair, we would write that negative 7, comma 0. All right. The y-intercept, again, I'm just going to replace x with 0 this time. Okay, so that gives me y equals the absolute value of 7. And absolute value is a distance. Distance is always positive. So the absolute value of 7 is 7. Okay, so this absolute value equation or function has 2 intercepts. One x-intercept at negative 7, 0. And one y-intercept at 0, comma 7. Okay, so we're going to use these x-intercepts to help us graph many types of functions now and moving forward. Okay, the ability to find these is extremely important. The x-intercepts have multiple meanings. We'll get into those. The y-intercept has, a couple meanings that can be very helpful for us when we're solving real-world problems. Okay, so that's how you find the x and y-intercepts for linear, quadratic, and absolute value functions, okay? And again, I told you I'd change this sign to a negative the way it should be, all right? So I did that, and that's how you find the intercepts.